So what we are going to do is this, that we have this yellow region bounded between the graphs of these two functions, okay? And then we have to revolve this region around the line y equals -3. And once we do that, we have to find the resulting volume, okay? So let us notice this, that this gx, this passes through 0, 0. So that means x-axis is tangent to this parabola, okay? So here we got our x-axis, all right, and we have to revolve around the line y equals -3. So notice this here, that if you look at the two options, this turns out to be an easier one for us. Let's take a vertical strip, and if we just go ahead and revolve it around this line y equals -3, what shall we get is, we shall get, see, this is what the outer side rounded will be, and this is what the inner side rounded will be. Now, if you look at the outer radius of this washer, what you have is this, that notice that this part equals how much? 3, just in the length it will be this depth, okay? And the top part corresponds to what? I just stretched it a little, little farther. So here we have to just remove it anyways. And then what we have is that so this part is 3 and this part is fx. So the outer radius is how much? Fx plus 3. Okay. Now if we go for the inner radius, okay, let's go for that right here. What we got here is that again, this portion here is 3, right? But so this is again 3, and then the rest will be given by which? This portion that equals how much? Gx, right? Okay, so the inner radius is Gx plus 3, okay? And the thickness is along the x-axis, so that's delta x. So the volume of the outer cylinder is, we can call it the outer disk rather, is this much times delta x, okay? And that of the inner is just with pi, so I'm just leaving it like this, times gx plus 3, which is the inner radius, delta x. And then, so what happens is you can write this element as fx plus 3 square minus gx plus 3 square delta x. And when you put them all together and take the Riemann sum, then you just get a definite integral to evaluate. And let's just go ahead and obtain it. But before we set up the definite integral, what we have to do is we have to obtain the coordinates of these points of intersection, or in other words, the coordinates where say the y values of the two functions equal to each other. So that means where we have this, okay? So if we square the two sides, what do we get? We get 4x to the power 4 equals 16 over 3 plus x square, okay? And since we are running out of space, yeah, actually we may not be running out of space. No, we have more space. So this is 4. So here we get 4 times 4 is 16. So x to the 4, then x square plus 3 equals 4. So that is x to the 4 plus 3x square minus 4 equals 0. Okay, so you can see this here. Yeah, I mean, I'm just reviewing pre-calculus. You can obtain these in your calculator if you want. That if they have any roots, they will be the rational divisors of -4 over the coefficient here, which is 1. So anyway, these are the candidates for the roots, and if you substitute x equals 1 in here, what do you get? 1 plus 3 minus 4 is 0. So one of the points of intersections is x equals 1, and what the other one will be? Just try -1. These are even powers, and this is going to be anyways even function. So the other one is x equals -1. So what we have to do is that our integral is going to be the integral from -1 to 1 pi times this quantity, like this is our big R. So big R is squared. Let's call it little r minus little r square dx. And what we are going to do is, let's just go ahead and automate this calculation, okay, by using our calculator, because we can do it by hand. It's not really that hard an integral, but it'll be just too time consuming. So let's just do it in our calculator. So here our first function is 4 divided by 3 plus x square. Let me pull this up a little bit. Okay, x square, and the function number 2 is what? Simply 2x square. So this will give us the point of intersection. I mean, we calculated it by hand, but just in case you're running out of time, so what we can do is we can go to second calc, and then we want the intersection. Okay, so this is the first curve, and then the second curve, and it's just giving us the intersection. And if you just scroll to the left hand side and increase the window, it will give you the other point of intersection. Okay, and I'm just going to change the window anyways from from -2 to 2 instead of just that. Okay, all right, and just we don't have to. I'm just using some extra time here for no reason. So now let's just go ahead and calculate the integral. So we can either use this option, number 7 here, or we can go to math, and you can see number 9 is giving us, oh sorry, I was on the wrong place. Okay, sorry about that. Okay. So here, so we can go to math, and then we can go to number 9 for the integral. So we are going from -1. What did I do wrong? Okay, let's just get that back. Okay, so what happened here? I don't know. Okay, let's check. So we have -1, right? And then we got a 1. Okay. And then we have what? Big R square, which is fx plus 3. And what is our f? We chose that to be how much? Our f was y1, right? So we'll go to vars, y vars, and then I'll choose y1, then plus 3, close the brackets. You get what after that? We square it, and then we have minus, and then we need our second function is what? The function y2. So we got this, and plus 3 again, squared, right? And then we have what? Simply dx. So the value of the integral is about 26.44. Now we forgot putting pi in here. So for the volume, what we have to do is we have to multiply the answer with what? With pi, and then the volume is how much? 83.0646 units. Okay. Now let's just do a similar question with the same region, and this time instead of revolving it around a horizontal line, we are revolving it around a vertical line, say x equals 5. So what we shall have here is this, that again, here again we have, it's easier to take a vertical strip because especially for this thing, we already have everything solved for y. So when we revolve, as I said, this strip around x equals 5, what we will get, we will get a cylindrical shell, and then what is the radius of this shell? The radius of this shell is going to be this, and say this is the x coordinate. So what you have is this, say if this is the x coordinate of these 2 points, there's a very thin vertical line, so x coordinates will be the same. So let's let this be x, and then what we have, the line is x equals 5, right? So what we have here is, this is 5. So the radius of the shell is going to be how much? The radius of the shell is going to be, which I sketched before. So that is going to be simply 5 minus x, okay? All right. So that's the radius. And what will be the height of this? We will have this y coordinate minus this one, so the height will be fx minus gx. So if we write down the volume of this elementary portion or elementary volume, this is 2 pi times the radius when you open it up, so that will be the circumference of the circular part, and then we just multiply by the thickness, the delta x, in order to get the volume. But first we have to multiply by the by this length, which is fx minus gx, and then we will integrate it from, we know that these points are, we just did, they vary from x equals -1 to +1. So again, this is even easier to calculate without calculator, than the example before. But still, let's just go ahead and use our calculator to work on it. Here, y1 is fx and y2 is gx. They are already entered. So we will go to math, then go to integral and start -1. Then we got 1, right? And then we have, this time I'm not forgetting pi, 2 pi times 5 minus x times fx minus gx. Now we don't have to write them again because we already have entered those guys. So y1 minus, and then we have again the functions. So we got y2 here, okay, and we close the parentheses, which is okay, and then we are integrating with respect to x. All right, so this should give us the volume. One moment, we have to put another parentheses here. Okay, so 96.1678 is approximately, these many units is approximately the volume that we had to find. All right.